Video we are talking about permutations and combinations. So that will be our prime focus in this video. Permutations and combinations, what are these things? Well, this topic basically just gets to show you the number of ways maybe an experiment can be done or achieved, because they just give you what we call the sample space. So we're basically just going to find a way of getting the sample space where if it has not been, of course, stated in the question. That's what this topic gets to achieve: permutations and combinations. So you need to have already an idea from the intro to probability what the sample space is. So I didn't advise in my earlier video that I had made on is it an intro to probability. Yeah, you have a look at it so that this topic even makes more sense. So let's get underway. We'll just start with the first one, permutations, in this video. Well, what are permutations? Well, basically they're also a way of finding the total possible outcomes that can be achieved in a given experiment or any investigation. Yeah, that's about a permutation. But there's something, or there's a catch to all permutations. What is this catch we're talking about? Well, all permutations have what? Order. There is order that is required. Okay? Permutations, there is order. So basically, what do we mean? You even actually get to see it in an example very soon of that same order. What I wanted just to share right now is that the formula, first of all, for a permutation. So you see this on your calculator, I believe. NPR. When you're finding the permutation, you might be asked, okay, calculate the permutation of this. Or if they haven't stated what to use it to know whether it's a permutation or a combination, what guides us? This word here. Is that selection requiring any order? You just ask yourself that question. That's how you know, okay, I deal with a permutation or a combination. So this is what you punch on your calculator. What I'm putting in a cap box right now here. That is what you should go punch. NPR. There's this symbol on your calculator. You'll find it. That's for a permutation. What is the N? The N is, should I say, they'll tell you maybe they want to try out a sample of maybe 10 things. Okay, you'll be like, okay, 10. Those same number of things that they want to try out is your N, the total number that you want to try out. R basically is how you want to now allocate those 10 things that you're now using. Maybe you want to, maybe allocate them in 4 slots, something like that. That's the R. R is basically how many ways do you want to do this? I want to do it in 4 ways, or that's basically the R. Okay, so this is how you'll be putting these things on your calc. N, you just go put there. So what you do is that when you press, first of all, press the number. This is how you'll be recording on your calculator. Press first of all, if it's 10, okay. Then what else do you do on your calculator? Say shift this detail on your calculator. Just say shift and press this detail in your calc. You'll see that this thing will appear on your screen, a P. Okay. Then what next? Put the R. Because just following like the formula there. The R, I said, okay, how many ways do you want to put this now? You want to allocate it in 3 slots or something like that. Here we said 4. Okay. Then you just go ahead and say equal to on your calculator, and the answer comes out. That's the calculator method. We have the factorial method as well, which is n factorial over n minus r close brackets factorial. So for a permutation, that is the formula for in terms of a factorial. Yeah. So n, same way, we've just analyzed it. You just be putting, okay, at 10 factorial over 10 minus 4 close brackets what? Factorial. That's all. And you just go punch. Factorial is always there on your calculator. It's this symbol, that exclamation mark. That's what we would call it in English. Yeah, in math it's a factorial. So you would always have to do shift of something, then this will be accessed usually. Yeah, basically that's how you do it. So let's look at an example. You might be asked, How many ways could a three-lettered word be rearranged? It's obviously a three-lettered word, and then be rearranged in what? In three possible ways, because it's got three letters. Yeah. So it's just about how we're going to rearrange this letter A. How many possible ways can A, B, C be rearranged? Since it's a permutation, yeah, there might even be the, okay, using permutations. Okay, so how many possible ways? And order is very key in this one. So you have your A, B, C. Which other way can you rearrange this? You can also say A, C, B. Okay. Any other way? Okay, for A, that's it. Let's start with B now. B, A, C. Okay. Then we should also have what? B, C, A. I believe these are the possible ways for starting with B. Then we can also start with C. C is okay, you can say cab, C, A, B. What about C, B, A? So of course, including itself, yeah, don't forget it. Kylie, okay, the verse two. Do not forget it. So the ABC, the ACB, okay, these are the 6 possible ways this letter ABC can be rearranged, in short. So what you just need to know is that order is very important. You might say, okay, how come they're all still starting with A? The whatever follows after that A differs from the first one. So for a permutation, that's what they mean by order. ABC and ACB, they are considered as 2 different things in a permutation. As you will see in a combination, they are not the same. They are just the same, if anything. They are just the same things. Now a permutation takes it that these 2 things are different, even though they're starting in the same letter. So you just say, okay, there are 6 possible ways. You can just count 1, 2, 3, 4, 5, 6. You even answer the question. Okay, if you had to punch this on your calculator, the sample species, how many digits have been picked? 3, right? That's your n. How many ways could this be rearranged? Well, if you still count, you can still have what? Three slots, This can be arranged. So your R is equally 3. You just go in your calculator, NPR, which is equal to 3 permutation 3. And you punch. That's it. So basically, on your permutations, this is what you just do. Yeah, there's no other trick and any other, should I say, funny methods, but basically this is your trick on a permutation. So I want to now actually shift our attention to a combination now at this point. Yeah, so a combination, basically, it's equally a way of calculating the total possible ways that can be achieved in a given experiment. But what's the catch? No order required. So no order required. That's the thing you need to remember about a combination. Okay, so what is the general formula for a combination? Well, on your calculator, you equally see this NCR. Okay, this C, of course, the C in the middle is your combination. So the way you just do a permutation is the same way we would approach this. Okay, if you told you 10 measures, same thing, 10 measures, that's your N. You want to maybe put them in what? Maybe you want to just maybe put them maybe 3. You want to assist out of those 10 measures, just want to 3 specific items maybe from there. So just say R is 3 and you punch this on your calculator. It equally has its factorial method as well. N factorial over N minus R, close brackets, factorial, and R factorial. That's for a combination. Just remember that if you've been asked to use the factorial method, or even though they don't specify, you can use any. Yeah, factorial method is just there where, yeah, you might not really know how to punch that NCR part on your calculator, then you just go this route. Yes, so basically that's that on the combination. I want to see an actual example. Yeah, then we'll come and equally use that same one which we started with as ABC as our ending example. But I want to see a very interesting example just now. So we have a good question there on the screen. A team of 4 is chosen at random from 5 girls and 6 boys. In how many ways can the team be chosen if there one, that's part one, there are no restrictions? So the question is just like that. They ask you how many post boys. Okay, you'll be like, okay, they're asking us to find how many post boys. So meaning, what comes to your mind is what? Permutations or combinations. Huh? They haven't specified. What will guide you to know which is which? Well, the team of 4 is chosen at random, 5 girls and 6 boys. So does it require an order in which they will be getting these 5 girls and 6 boys? They just want a team of 4 from 5 girls and 6 boys. Huh? So they can, if you want, you can choose 2 what. There's no really a specific order. That's how you just tell from the question. So let's go ahead and answer now that we've realized that there's no order, meaning we are applying combinations. So let me show you how to answer A1. There are no restrictions. Huh? Of course, first one, find all possible ways. So when finding total possible ways, you ask yourself, how many individuals are there first of all? The N. Well, we have 6 girls, 5 boys, right? That's 11 in total. How many do you want to select from there? That's usually your R. That's what I said. N is usually just, okay, how many observations are there, measures that you want to take? The 11 people. R, how many do you need from those 11? Just 4. And you're done. You're using combinations. Just do this. 11, you go on your calculator, C, and then your R is 4. You'll get your answer. So you punch this 11 combination 4, it gives you 330. That's your total possible ways this experiment can be done without any restriction, because there's no restriction. Just find the total possible ways. That's part 1. Part 2 says what? There must be more boys than girls. More boys than girls. So you want to find the total possible ways that this can be done, that there must be more boys than girls. Okay, they want to choose 4, and you want to choose more boys than girls out of these 4. How many 2 ways can this be done? You can either say, okay, 3 guys or 3 boys and 1 girl, or you can also say 4 boys and 0 girls. So that's the scenario. So let's just do that for part 2. So for part 2, I think there are 2 ways this can be done. They want more boys than girls. Huh? You can either say, as we said, 3 boys, I'll say 3B, and 1 girl, 1G. Then you can have what? 4 boys and 0 girls. So it's this group of selection or the other one. So there's 2 possible ways you can actually get to have more boys than girls. Huh? So you start with the first one. How many possible ways can you choose? Of course, 3 boys and 1 girl. Well, the question, if you go back to it, it said that there are about 6 boys in total. So okay, check for the boys. How many boys for the boys alone first? That's 6. That's your N. And then R will be what? How many boys are now being selected? 3. Okay. Since it's and girls, they are supposed to be picked together simultaneously. So it's like boys and. So the moment you just hear that word and, we're applying multiplication rule. We're multiplying the 2 chances of picking the 2 events. The girls, how many are they? There are 5 in total. That's your N. They wanted to choose according to the first theory. One choose, okay, 1 girl. That's according to our first theory. If you multiply this together, it gives you 100. That's the first scenario, right? The other one is 4 boys and 3 girls. Follow this arrow. 4 boys and 0 girls. So, okay, how many guys are there? 6. Okay, how many do you want to pick in this scenario? 4 times, since it's and, okay, according to that scenario, 0. Then you have your 5 total girls and 0 in this scenario. What does it give you? 15. So what is the probability of choosing, of course, more boys than girls? It's either this one, the 100, the scenario which had 100 as a total sample space, or choosing maybe 4 boys and 0 girls, which gives a sample space of 15. And since it's this or that, then we just hear or, we're going to add our findings. Or is just an additional rule. Let's to talk about that. 115. That's your part 2. That's how you get it. Let's answer the other part of the question quickly. So part B is saying find the probability that the team contains only 1 boy So the team has been selected. Now we want to find the probability that the team contains what? Only one boy. So the desired event is okay, a team having one boy, and if you have one boy, meaning how many girls will be picked? Since they are choosing 4 in total, 3 girls, right? So they are making up a team. Do not forget the girls part as well. They are saying the team will only have one boy. So one boy meaning 3 girls. So first of all, that's the desired event. First of all, that one boy. And of course, if you choose one boy, then it's 3 girls. So you get that sample space, the total number of this desired event over the total sample space. How many possible ways can all these be selected? So it gets back to that intro video and probability. How do you get the probability of an event to occur? So I'll just explain very soon on this screen. First of all, from theory, we know that probability of an event, maybe event A to occur, is what? The number of that desired outcome over total number of the sample space. Okay, what's the total number of sample space? The total possible ways this whole entire experiment can be done, which is what we started with on part A. How many ways can this experiment be done? Of course, without any restrictions. First of all, that's the total sample space. So you just know total possible ways something can be done. And we got 330 if you rewind in our video. So it's like our NS has already been done. It's 330. That's our sample space. Then now, what is the desired event? One boy can be selected in this team. Meaning if it's one boy, 3 girls. Get also that part, the NA, which is the desired outcome of having one boy in that team. So if you have one boy in the team, what would this be equal to first of all? Remember, we are applying what? Combinations. We said there's not necessarily any order. You're just selecting one guy. It's not like they should come in a fashion or anyway if you really think about it. So how are you going to do it? Okay, we're getting the as well the total number of choosing, of course, one boy and what? How many guys are there? There are 6. You want to choose what? One boy. Okay. Times, because it's in a team of a boy and, so that's why we've been putting times, because and girls are at 5. Then okay, then what else do we need to know? There are, if you choose one boy, there aren't a total of 4, 3 girls. What's the total there if you multiply these things on the screen? Okay, that's your 6 combination 3. So it's combination 1, it gives you 6 times 5 combination 3 gives you 10. So this gives you 6 times 10 is 60. By the way, that's the total you get there. That's your NA. This qualifies as your NA. That's how you get it. Then what is probability? Probability is what? The NA over the NS. Probability of an event to occur. Just all goes back to the basics. So if you got your theory or your intro well, you will not struggle with this. Trust me. So 60 divided by 330. It gives us, let's just take it as a fraction because it's giving us a lot of decimals, 2 to 11. And when you're putting probabilities, 2 over 11, sorry, and when you're answering probabilities to the what? Smallest, simplest form. And that's how you get to answer these questions on permutations and combinations. And I promised that, okay, that example we used, the ABC, if it was in terms of what? Combinations, maybe specified, how would you have answered? How many possible ways can this be rearranged? Well, if it's terms of what, in terms of what, combinations, this one is what? A, B, C. So there is no order. So if you start doing this, then you're now becoming a permutation, because for a combination, order is not really even important as such. You don't even need to start rearranging it in any way. So ABC is the same as ACB in a combination. That's why you don't even write such. Yeah, there's not necessarily any specific order. Unless maybe you said, okay, I'm not starting with what? With B. Maybe I'll just say, okay, BAC. That's it. You can't start saying, what about BCA for a combination? No. BCA, BAC, they are one and the same thing. That's why we do not even do this in a combination. So far, you only have 2 ways you can do that. The final way, maybe it's okay, you're starting with C this time. Maybe CBA. So basically, combination, no order required. That's just something to remember about AOS is a combination. So ABC, they are just, if anything, ABC, BCA, these things, they are not even necessary. So even though you would change the order, you start with C, start with A, start with B, combination, there's only one way this can be done. That's it.